Hello. So today we'll be looking at polynomials. Now, what are polynomials? Polynomials are a mathematical expression made up of variables and coefficients, which are combined using addition, subtraction, multiplication. For example, we have 3x square minus 2x plus 1. This is a polynomial, and in this polynomial, x is the variable, as you can see, and 3, 2, 1 are the coefficients in the polynomial. Now, every polynomial has a degree. So the degree is nothing but the highest power of x that we have in the expression. So for instance, if we look at the polynomial px is equal to 3x cube minus 4x square plus 2x minus 5. So in this, the highest power of x is 3. Therefore, this polynomial is a degree of 3. Now, types of polynomials. So polynomials can be categorized into different types based on their degrees, basically. So the first, we have constant polynomials, which is just your constants. For example, 1, 2, 3, 4. The next comes linear polynomials, which have a degree of 1, which, for example, 2x plus 3, 4x plus 5. These are examples of your linear polynomials, which have a degree of 1. Next is quadratic polynomial with a degree of 2, which has an example as x square plus 4x plus 1. Now, cubic polynomial would have a degree of 3. For example, 3x cube plus 2x square plus x plus 3. So now each of these polynomials have a unique characteristic and a different graph shape. We will see in the later parts of the chapter. Now moving on, the value of px for px is a notation for a polynomial. So the value of a polynomial for a real number k. Now, say for example, we have polynomial as px. Okay, and we take any real number which is k. So the value of px at k would be nothing but substituting k in place of x. Now we'll understand this with the help of an example. So if we calculate the value of px is equal to x square minus 3x minus 4 at x is equal to minus 1. So what we will do is we'll substitute minus 1 in place of x. So we can see minus 1 square, 3 multiplied by minus 1, minus 4, which will give us 0. And the same time we look, if we put 4 in place of x, then that would also give us a 0. So as we can see, p minus 1 as well as p4 are zeros. So therefore, we call these numbers zeros of the quadratic polynomial. So here it is written minus 4 and 4 are the zeros of the quadratic polynomial x square minus 3x minus 4. So in general term, any real number k is said to be a zero of a polynomial when pk is equal to 0. That means when we substitute k in place of x, the whole expression comes to 0. Then that value is called a zero of the quadratic polynomial. Now moving on, zeros of a linear polynomial. So this is pretty simple, but we'll go through it once. So for example, we have a polynomial 2x plus 3. The degree is 1, x highest power is 1. So this is a linear polynomial. Now, to calculate the zero of the polynomial, what we'll do is we will equate this term to 0. So now putting k into it, so pk would be equal to 2k plus 3 is equal to 0. So k would be turn out minus 3 by 2, as you can see here. So minus 3 upon 2 is a zero of the linear polynomial 2x plus 3. So in general term, k is a zero of a linear polynomial, then the value of k would be minus b upon a. So now we know b is what? B is the constant term in the polynomial and a is the coefficient of the polynomial. So in general notation, we can write that the zero of a linear polynomial is this constant term upon coefficient of x. And remember one thing, people tend to make a silly mistake that no matter the sign of the constant term, a negative sign will always be placed for calculating the zero of a linear polynomial. So just keep this in mind. So this is the formula for the zero of a linear polynomial. Now moving on, we have the geometrical meaning of zeros of a polynomial. So in this slide, we calculated it through variable and coefficients. Now we'll calculate the zero using graphs. So we take the same example, 2x plus 3 here. So 2x plus 3 what we do is we draw a graph. So the graph of 2x plus 3 would be a straight line. So we jot down the points, we draw the graph. Now we can see that this is the x axis, this is the y axis. So this line 2x plus 3 intersects the x axis at exactly minus 3 by 2 comma 0. And in the previous slide, we saw that minus 3 upon 0 is also the 0 of this polynomial linear equation. So thus we can say that the zeros of the polynomial are the coordinate where the graph intersects the x-axis. So this is the proof for it. So does the 0, see the last line, thus the 0 of the polynomial 2x plus 3 is the x coordinate, which is this point, x coordinate of the point where the graph y is equal to 2x plus 3 intersects the x-axis. It is pretty simple for a linear polynomial. Now we will see. So zeros of a linear polynomial. So now these are just the things to remember. So in general terms, for a linear polynomial ax plus b, the graph of y is equal to ax plus b is a straight line. We saw that the graph of 2x plus 3 was like this, which intersects the x-axis at exactly one point, which is this point here, namely minus b by a comma 0. This would be the point. Therefore, the linear polynomial ax plus b has exactly 1, 0, namely the x coordinate of the point where the graph of y is equal to ax plus b intersects the x-axis. So reiterating this point here that we have of the straight line on the x-axis, this is minus b upon a is the 0 of the linear polynomial. Now moving on, we'll look at zeros of the quadratic polynomial. So we take the example of x square minus 3x minus 4. So we calculate the points here for graphing. Now moving on, this would be the graph of a quadratic equation x square minus 3x minus 4. These are the 8 points that we have plotted on the graph. So here also we'll see this is the x-axis, this is the y-axis, and here also exactly 2 points the graph cuts the x-axis at. So now we see these 2 points are the zeros of the quadratic equation x square minus 3x minus 4, which you also checked in the examples previously. So here also we can clearly see that the points the graph cuts the x-axis at are the zeros of the quadratic equation. So now this shape that you see, the U shape, is called a parabola. So now more on the parabola. Whenever we have quadratic equation ax square plus bx plus c, the graph of a quadratic polynomial will always be a parabola. Now the parabola can be two ways. It can either open upwards or it can open downwards. See, when it opens upwards, it means the coefficient of x square is positive. And when it opens downwards, that means positive. That means that the coefficient of x square is negative. Okay, so the graph only depends on the coefficients of a. So a greater than 0 would be, coefficient can be anything, 1, 2, 3, 4, and a less than 1 can be minus 1, minus 3, minus 5, minus 10, and so on. So this is about parabola. Now moving on. So in graphs of quadratic polynomial, we have different cases. So here you can check in the first figure. See, the graph is facing downwards. So that means a, our coefficient of x square, will be less than 0. And here the graph is pointing upwards, opening upwards. So the coefficient of x square would be greater than 0. So now this case says that this is the basic which you saw before also. This is the same. Here the quadratic polynomial cuts the x-axis at 2 points. So a and a dash are zeros of the quadratic polynomial. So this is the basic case that you get in any quadratic polynomial. Now moving on, we have case 2. Here if you look closely, in our previous shape, the parabola touched the x-axis at 2 points. But here it only touches the parabola, the x-axis, at 1 point, that is a. So that means a, in this example, a and a dash coincide and becomes a. So this means that this quadratic equation will only have one zero, which is a. And just as a point to always remember is this in here, in the first figure, a would be less than 0, and in the second figure, a would be greater than 0, which is the coefficient of x square. Now, moving on to case 3, we have now, look in this figure, this is very interesting. In both the previous cases, the quadratic polynomial graph touched the x-axis either at one place or at two places. But here, the graph is completely above the x-axis and does not touch any point in the x-axis. So this means that the polynomial that we have, ax square plus bx plus c, has no zero in this case. It has no zero. There is no, we cannot solve the quadratic polynomial. So this would be the case 3. So in case 1, if you remember, we had two zeros. The graph touched at 2 points. In second case, we had 1 0. The graph touched at exactly 1 point. And in third case, we have 0 zeros. So the graph is somewhere above the x-axis. So these are the three cases that are possible in the graph of a quadratic polynomial. Now, moving on. Now, just to recap what we learned, geometrically, we have seen that a quadratic polynomial can have either two distinct zeros, that means case 1, or two equal zeros, that is 1 0, that means case 2, or no zero, that we saw in case 3. This shows that a quadratic polynomial of a degree 2 has at most two zeros. Kindly remember, this is a very important point. Okay, now in general terms, now we will generalize all that we have learned. In general term, given a polynomial px of degree n, then the graph y is equal to px intersects the x-axis at most n points. In the previous examples, we saw that the n was equal to 2. So our zeros were maximum 2. So this is exactly what we are saying here. If we have a degree n polynomial, then the max n zeros we can have. This is what this statement is trying to say. Now, moving on, here we look at a cubic polynomial. Cubic means the degree of a polynomial is 3. Okay, so the example that we have is x cubed minus 4x. So first we plot the points that we have calculated for x and y, and these are the points that we get for plotting, and this is the shape. This is a wave shape that we get for the graphing the cubic polynomial. Now, if you look this x-axis, the wave touches the points, the x-axis at 3 points, mainly minus 2, 0, 0, 0, and 2, 0. So does now try to remember what we learned in the previous while graphing the quadratic as well as the linear equation. So here we can deduce that this equation has 3 zeros, mainly minus 2, 0, 2. These are the 3 zeros of the quadratic equation x cubed minus 4x. So how did we come to this conclusion? We saw that this graph intersected the x-axis at these 3 points. So these 3 are the zeros of the equation x cubed minus 4x. Okay, so now moving on. See, I've prepared some questions that you can do after seeing this video. These are pretty easy questions. What you have to do is, we have to find the number of zeros of px. Px is a polynomial, and by the shape of the graph that you can see, you will be able to guess which polynomial it is, which degree of polynomial it is. So try to do these questions, and thank you. See you in the next video.